In this video, we're going to be discussing simplifying radical expressions. So a radical expression is just a expression that has a radical in it, some sort of root. And in order to simplify them, we need to talk about perfect numbers first. So a perfect square is a number where if we take the square root, we get an integer. For example, the square root of 36 is 6, so 36 is a perfect square. A perfect cube is a number whose cube root is an integer. So 125 is a perfect cube because the cube root of 125 is 5. A perfect fourth is a number whose fourth root, I should say fourth with a U, okay, whose fourth root is an integer because the fourth, for example, 81 is a perfect fourth because the fourth root of 81 is 3. And radical expressions that are not perfect can be simplified. We're going to discuss how to do that in this video. Now, in order to help you with that, these are the first 20 perfect squares, perfect cubes, and perfect fourths. So, for example, they start with 1. So this is 1 squared, 1 cubed, 1 to the fourth, and they go to 20. 400 is 20 squared, 8,000 is 20 cubed, and 160,000 is 20 to the fourth power. And we're going to be using these numbers as we simplify our radicals. So let's talk about the steps to simplify a radical. So our first step is going to split a number into two factors, a perfect number and its factor pair. We're going to put the perfect number in one radical and the other number in the other radical. And then we're going to take the root of the perfect number and leave the other number alone. So let's take a look at some examples of how that's going to work. So I want to simplify each one of these radicals. So here I've got the square root of 150. So what I want to do is I want to find the biggest perfect square that is a factor of 150. And it just happens to be that it's 25, because 150 is 25 times 6. So I've got my perfect square over here and my non-perfect square here. My perfect square, I'm going to do the square root of that. The square root of 25 is 5. And the other square root, 6, I'm just going to leave underneath there, so I get 5 times the square root of 6. For part B, I'm going to do the same thing. So 448, the biggest perfect square that goes into 448 is 64. And 448 is 64 times 7. Okay, so if I do the cube root of 64, I get 4. And I leave 7 under my radical, so this becomes 4 times the cube root of 7. So I'm just finding the biggest perfect number that goes into each one of these. And I'm doing the root of that. And I'm leaving the non-perfect number underneath the radical. Here I'm doing the fourth root of 80. The biggest perfect fourth that goes into 80 is 16, and 80 is 16 times 5. If I do the fourth root of 80, I get 2, so this is 2 times the fourth root of 5. All right, so the process, once again, find the perfect number, the biggest perfect number that's a factor of the number of your radicand. Split your radicand into that perfect number and its factor pair. Do the root of the perfect number and leave the other number under the radical. Now, what if we have a variable under our radical? Well, if a number has an exponent that is a multiple of the index, then it's a perfect number. For example, x to the 18th is a perfect cubed because 18 is 3 times 6. So to simplify the radical, you simply divide the inside exponent by the index. Remember, converting to rational exponents. So for example, I've got the cube root of x to the 18th. Well, that's x to the 18 divided by 3, and 18 divided by 3 is 6, so that's x to the 6th. If I gave you something like, for example, the square root of x to the 6th, well, 6, remember our index here is 2. 6 is, ooh, that looks bad. 6 is not a multiple of 2. All right, so, well, I'm giving you a bad example. Let's not use 6 because 6 is a multiple of 2. Let's do x to the 9th power. X to the 9th will work. Okay, 9 is not a multiple of 2, so I can't just do this dividing. I've got to split this up, just like we were doing with our numbers. So I want to think, what's the biggest number that's smaller than 9 but is a multiple of 2? Well, that's x to the 8th power. That's a perfect square. And x to the 9 divided by x to the 8th is just x. Now I'm going to put both of these under radicals. The square root of x to the 8th is 8 divided by 2, so that's x to the 4th. And this x, because it's not a perfect square, just stays under the radical. So the square root of x to the 9th is x to the 4th times the square root of x. So let's apply this to an example. Okay, it says simplify this radical. And I've got the cube root of 108, x to the 7th, y to the 12th. So this is going to take quite a bit of stuff to do. First off, we want to break these numbers down. So I'm going to work with 108. All right, so the biggest perfect square, or the biggest perfect cube that goes into 108 is 27. And 108 is 27 times 4, so I can split this up into 27 times 4. X to the 7th is not a perfect cube. The biggest perfect cube that goes into x to the 7th is x to the 6th, and x to the 7th is x to the 6th times x. And y to the 12th, because 12 is a multiple of 3, y to the 12th is a perfect cube all on its own. Once I've got them split up like that, now I'm going to take all of my perfect cubes, and my perfect cubes here are 27, x to the 6th, and y to the 12th. They go in their own radical. And my non-perfect cubes, 4 and x, they go in their own radical. And now I'm going to do the cube root of my perfect cubes. So the cube root of 27 is 3. The cube root of x to the 6th, 6 divided by 3 is 2. The cube root of y to the 12th, 12 divided by 3 is 4. And my non-perfect cubes just stay inside of the radical. So my answer ends up being 3x squared y to the 4th times the cube root of 4x. All right, so I'm going to leave you with this try it problem. I want you to simplify this radical, the 4th root of 512 x to the 18th power.